reason for your answer. Yes, Aidan.
And there is a third one with the 6.2 times 10 to the minus 5.
Succinic acid now.
Okay, so he's saying that it's this one, 6,2 times 10 to the minus 5. However you say that, cerebral acid. Does it matter that I can't even say that word? It really doesn't matter because it's all irrelevant. This could have been an X acid, Y acid. It really doesn't matter. They give you what you need. So please, if you see a word in the exams that you've never seen before, don't think, oh, they haven't taught me this, I'm blank, I'm going to cry. Try and look at the question and see, trust your training, you can do this. Yes, Enzo? You said some, oh, okay. So which acid is the weakest one? So it's that one there. And then it says, give the reason for your answer.
The exponent. That's the smallest exponent.
Exponent. The small, lowest Ka value. That's it. Exponent, no, that one is the lowest exponent.
No, man.
Biggest negative, then you have to say biggest negative exponent.
Oh, yeah. That's what I meant.
Yeah, remember maths and science is negatives and positives are a bit confusing. So just say it as the smallest Ka value. If I say, how can you prove this in a lab if I don't give you these Ka values and I give you these acids and I say they all have the same concentration, Horsey, what will you do in this lab to prove to me which of these acids is as the high, I almost said the answer, is the strongest? But how do we measure the concentration of an acid in a lab? TK.
Titration?
Titration will give me the concentration of one of them. Then I must do it for all of them, and now I have the concentrations. I don't have the... Then I told you from the start that they all have the same concentration. So aren't you wasting a bit of time doing titrations to get me the concentration?
Yeah.
If I tell you that they all have the same concentration, Alex, you can answer this always. Yes.
It's electrical conductivity.
Thank you. You're going to send an electric current through them. Which one's going to conduct electricity the best? The strongest one, because it's going to form more ions. You can even say it's the best electrolyte. Because what is an electrolyte?
Free moving ions.
There, can you see you're using your definition again? In this chapter, if you know your definitions, it's 40% done. Really 40%, not 10%. I mean, I actually counted how many in the test, how many answers are definitions. And they're not all level 1 questions, but they're all definitions. Because as soon as I say what's the difference between a weak acid and a strong acid, it's not level 1 anymore, it's level 2, but it's actually still level 1 because it's just your definitions. Yes?
Should I do the next one?
The next question says, yes, it says define an amphiprotic substance.
The substance that can act as either an acid or a base.
Acid or a base. So now they tell you here, oxalic, so this is going to get to your answer, Thomas, yes. It says oxalic acid is this, and that is amphiprotic. So they're giving you the oxalic acid. Guys, this is important. Everett, this is important. So if I take that acid, the H2C2O4, will it ionize in water or dissociate? It's an acid, guys. It ionizes. Acids ionize. They both start with a vowel. Acids ionize. So what am I going to write here? Lindor.
Plus water.
Plus water. And that is going to single arrow or double arrow socks?
4 ions.
Double arrow, because this is not one of the 3 strong acids that we know. Okay, so you're going to put a double arrow. Then what is this ion here going to be, Everett? What is an acid? What is an acid? So it's going to give one of its protons to the hydrogen, to the water. So that one hydrogen is going to disappear. I still have the one hydrogen. C2O4. So that means we've donated one proton. can this donate another proton? How many protons can it donate?
2.
So what do we call an acid that can donate 2 protons? Nice. Diprotic. Thank you. Now, can you see, this is what they actually gave us. So this is my amphiprotic substance because it still has a hydrogen. So it just took a hydrogen, so it could act as a base, but it can also act as an acid. This is very important. So this is my acid. And then the thing that it forms, that only differs by one hydrogen, is going to be the, what do we call this? The conjugate base. Yes. This one here, so that water is taking the hydrogen, so what does it behave as? It behaves as a base. Now if I go to this side, what is this then going to be? Conjugate acid. What is the difference between this and this? One hydrogen. So they only allow to differ by one hydrogen, and that's how you spot them. Okay. Please, guys, that is important. That it was in a few past papers now already. So amphiprotic substance, so tell me which of these, oh, they told you. But if they didn't tell you, how would you know which of these substances is the amphiprotic one? It has to have a hydrogen, because if it doesn't have a hydrogen, it cannot give a hydrogen, so it cannot be an acid. So that you have to look for something that has a hydrogen. But it must also be able to take a hydrogen, so it must have a negative charge. Look out for that. If we ask you for something that is amphiprotic, it needs to have a hydrogen so that it can give a hydrogen, but it must also be able to take a hydrogen. Yes.
So normal water will be the only amphiprotic substance that doesn't need to have, that can be neutral and still be amphiprotic.
No, there are others, but for an acid. Yeah. It's not, guys, it's not always the case that they're going to be negative. Water is amphiprotic because it's got 2 hydrogens. It can become H3O plus, or it can become OH minus. So it can lose a hydrogen and it can give a hydrogen, but it started off neutral. So whenever it can give a hydrogen or take a hydrogen, it is called an amphiprotic substance. The next question says, write the formula of the conjugate base of that.
Of that ion.
Yes. Now be careful. Okay, this reaction that I wrote here is to form this. Where do the conjugates sit? On the left or the right? If you look at this reaction, where do the conjugates sit? On the right. Okay, so please, if they ask you for this one, they want the conjugate base of that. So that means this must be on the left. So you're going to say HC2O4 minus plus another water. They didn't ask you for the reaction. But because now here it was the conjugate base. But now they're asking for its conjugate base, so it needs to behave like an acid. So does it behave like an acid now?
Yes, ma'am.
Yes, what's it going to do? It's going to give its hydrogen there. And what am I going to form in this case? Andreas? Yeah? C2O?
4 2 minus plus H3O.
Nice. So, is that what you said? Yes, then you were right. I thought I heard an H. So, this is my acid now, and this is my conjugate base. This is my base. No, you wouldn't have to write all of this. this is my conjugate acid, but this must go in your brain because they're asking for the conjugate base of that. So if they're asking for the conjugate base, it must differ by one hydrogen. So what you need to think is, am I going to add a hydrogen or am I going to take a hydrogen away? Okay, if it's acting as the conjugate, if you want the conjugate base, this must be an, guys listen now. If I need the conjugate base, this must behave as an acid. So it needs to give a hydrogen away. So what's left? Just C2. So I wrote more than what you would write in an exam, but I want you to see where it comes from. So all you would have written down was C2O4 2 minus because it got rid of an extra hydrogen. Yes.
Why did it go from O4 minus to O2 minus?
Because it got rid of an H, and remember an H is plus. So here it had a minus charge already. Now it's giving away a hydrogen. That's why the water became plus. The water was neutral, it became plus. This was -1, becomes -2. All right, moving on.
Is water the only amphiprotic substance that doesn't need to have a charge?
No, there are others, but it's the common one.
In order for something to be amphiprotic, it has to have a charge, like a negative charge or something.
And
Like hydrogen.
if it's an acid-base reaction, yes. Yes. This is still weak, so it will still be a double arrow. Yes, sorry. Guys, please remember that for all purposes in the IEB, we see every donation. If it's a strong acid, we see, and there are 2 hydrogens or 3, whatever, we see every donation as strong. If it's weak, we see every donation as weak. So you don't have, the Ka values are going to be different, but you don't have to worry about that. All right, now, very important again. Why did we choose this?
Oh, yes.
Oh.
It's not it.
There's no hydrogen oxidate.
Hey,
Break it up
they
into
give it to
ions.
you.
No, but they confuse.
Yes, so guys, no, this, yes, this is also, again, you're going to read this and you're going to say, oh my goodness, what did they do to me? They're giving me something that I've never heard of. Potassium oxalate is an acidic, basic or neutral salt. Now, trust your training. Please tell me, what is a salt? The definition that you learned for yesterday. Yes, Lindor. Lindor.
A salt is a substance in which the hydrogen bond is replaced with a cation. The hydrogen bond of an acid is replaced with
The word bond doesn't belong.
a hydrogen atom. The hydrogen of an acid is replaced with a cation.
Cation. So if you look at K2C2O4, where's the cation? Yes. So this is my cation. So if I look at this, the acid that would have formed this was H2C2O4. This is the acid that formed it. And the base, we don't really care about, but we know the back is the base. Okay, so now, this, is it a strong or a weak?
Weak acid.
We know it's a weak acid.
It's not actually sulfate.
K is in which group?
K is in one.
So what can you tell me about that? Came from a strong base. So shortcut. What do you know about this salt already? Okay, so you already know. Tick 1 mark. You know it's going to be a basic salt. But in this question, are you going to get any marks for saying that? No. So what your next thing is to choose the ion from the weak one. So what would that ion be that comes from a weak one, Kriston? Thank you. So we're going to take away the cation, And you're going to say it's the weak one. So it's the C2O42 minus that is now going to undergo hydrolysis. And you know your definition for hydrolysis. So what are you going to say? Thank you, because you know hydrolysis is the ion of the salt that reacts with water, and hydrolysis will always have a single or double arrow.
Double because weak.
Guys, this is weak, remember? So it's always going to be a double arrow. This is negative, so it's going to take C2O4.
It's not H,
H2C2O4. So we're going back to that acid that we decided on in the beginning and that I think the question gave you. No, they never gave you the
H's
formula.
though. because
They
it's
gave
H.
you the formula for the acid, yeah.
Should we get
Should not only give one.
hydraulic?
Yeah, I think we should only get one. Otherwise, it's just gonna be.
You should only give one and then you have OH minus.
Yeah.
Charge is two minus.
You know what I'm saying?
No, but now your hydrogens are not balanced. And that's all.
Yes, it should be one hydrogen.
No, you can't do that because you need to balance this. You can do that though. And you can do that.
Oh,
No, it's still not balanced.
no, it's 4-4.
But in a hydrolysis reaction, I don't think they really care about balancing, to be honest.
Still take a
Now, what is the next very important step you're going to write down? How do we, from this, how do I know that this is basic? So you're going to say the pH is not going to be 7, or you actually don't start there. I would say the concentration of my OH minus ions will be bigger than the concentration of my H3O plus ions, and therefore
pH is greater than 7.
pH is greater than 7, therefore basic salt.
Yay.
Can we still do the K plus reaction?
No, because it's.
You can, but it's pointless because it's strong. If you went K plus water for hydrolysis, now the problem here, let's leave the arrows out first. What it would like to form is KOH plus H plus. Okay, but now this thing here, what do you know about it?
Single arrow.
And that's why we don't write that reaction, because it won't take place.
So,
So do you always, do you always take the weak acid, or you always take the acid and mix it with water?
No, you take the weak one. If it was a strong acid and a weak base, then you're going to use the base ion. So they would say it was magnesium.
And this would be the substances like the, but and they both weak.
We won't ask you that, because then we have to give you the Ka values, and you need to compare that, but we won't do that. They don't do that.
we have to write the proper acid on the right hand side. So we can't have a charge. Remember what I did before? I said HC2O4 minus. So we can't do that.
The HC2O4 minus, yeah, like this one.
That's what I did. Then I said plus OH.
Oh, that's also fine.
Okay.
You're still forming OH minus. Oh, that's what you mean. Yes, you're absolutely welcome to do that. Guys,
So I don't have to
come.
balance it.
All right, this was the next question. Okay, then they say the acids in the table were all white crystalline solids at room temperature. The students were required to identify a sample of one of these acids by titration. So you're obviously going to get a titration. I hope you know that. with a standard solution of sodium hydroxide. An acid may be presented as H2A, and the equation for the titration is as follows. So this is when we don't really know what we want the acid to do something, but we can't find a real life one, so we go and make up one. So that was just a made up acid, but it doesn't matter, because what do we know about the NaOH? It's strong. So it's always going to be a one-way arrow, because the NaOH will drive the reaction, because it's strong. Right? So this reaction takes place. They tell you 1 gram of the unknown acid was dissolved in distilled water and made up to a volume of that. 25 cubic centimeters of that solution. Now this is where you need to focus. Please, this is happening in every single titration question. So chances are it will happen in your test and in your exam. They always make a big bunch of it. And then you use only a small amount. In your titration calculation, which of those two are you going to use? The small one. It seems silly now, but you know how many times in an exam, you people go back and look for the volume and they pick the wrong one. So please, when you're reading your question, highlight the one that we actually are going to use. So this is our unknown acid. We don't know. And we also don't know what that acid's concentration is. But we're titrating it with an NaO of concentration that. So what do we call this solution? A standard solution, because we know the concentration. So remember what I said, you're always going to start with your standard solution. So whenever you do a calculation, you know that you're going to start with your standard solution. I'm just writing it there for now. Then they say after a few runs of the titration, the average volume of the NaOH used was 23.5 centimeters cubed. So they're giving you the volume of the standard solution is 23.5 centimeters cubed. What are you going to do immediately to get a mark?
Decimeters.
You're going to say this is 23.5 times 10 to the minus 3 decimeters cubed. Oh, just decimeters, not minus, sorry. Okay, then they say name the apparatus containing, so this is remember I said to you there are 2 experimental procedures that you have to know for your exam. There's practical questions going to come out of titration, and practical questions going to come out of making a standard solution. So please, but for your test on Monday, on Wednesday, I'm not going to ask apparatus because you've got the prac on the same topic next term. So, but what do we call that thing with the NaOH in it, Itu? You're joking, this thing.
A burette.
It's a burette, guys. That is a burette. Yes.
I thought you said we had to use the volume 25.
Oh, sorry. This is the unknown acid. So this 25 is for the acid, for this H2A. This volume is for the NaOH. So keep the information separate on your exam so that you don't get confused with it. Guys, that is very important. I would actually highlight them in different colors if I was you. All the information that goes with a standard solution, highlighted in one color. All the information that goes with the unknown, highlighted in one color. Okay. Then they say, what is the apparatus used to transfer 25, exactly 25? What is that little thing? Pipette, yes. And then these two, you need to know the difference between an equivalence point and an end point. I did ask you that yesterday. Equivalence point is where the neither is an excess, and end point is the color change. And then they ask you to calculate the concentration of the unknown one. Can you do that?
You want to do it now? No.
You don't have to do it now. We've got 3 minutes left. But can you do